And welcome back. It's been a little while since we've done a video on the solar system here, and there'll be a lot more videos coming on our particular solar setup, as well as some expansion once it starts to warm up outside and we get into the spring and summer. But let me start out by saying what you're going to see here is just what I've chosen to do. I am not an electrician. I am not a certified electrician, nor is this a how-to video. You should always consult a certified electrician if you need work done, any type of wiring work done, especially if you were uncomfortable in doing that work yourself. What you see here is just an expansion box that we've got mounted to a floor joist. And what I usually like to do on these floor joists is just drive some extra screws in on each side that you see there to help secure that box. And what we're going to do is we're going to take the sub panel that runs the solar system and run a 50 amp feed and tie it into the circuit panel or breaker panel that's in the garage. And when the garage was originally built, it's being driven off a panel that when they moved the power meter, they put a outside meter base / breaker box on the outside of the house, and they ran the garage panel off of it. Well, we're going to take their 50 amp feeder line and tie it into the breaker panel that the solar circuits run off of. And rather than tear apart a good section of drywall on the inside of the house or a good section of the walling in the garage to gain access to the panel, we're going to run it down here in this junction box and basically just splice the two lines together. And again, this is just the way that I've chosen to do this. I am not a certified electrician, once again, and once again, this is not a how-to video. This is just more just documenting the process, because splicing these two lines together to get that garage panel onto the solar system is by far, at least for me, a much easier task than, like I said, tearing apart either an inside wall or an exterior wall to get to that panel to run a continuous feed. Now, don't get me wrong, the ideal setup would be to tear that wall apart and run a continuous feed from the solar panel into the breaker panel of the garage. But I just don't have the capacity to tear that wall apart and have to recreate it. And I'll bring you inside the garage and show you a little bit better scenario of exactly what I mean and why it's a little bit more difficult to do that. But in researching, splicing those wires together, and what it is, it's a 6-3 feed that goes to the garage, and we'll be running a 6-3 feed from the solar panel and then just splicing those two lines together. And doing a little bit of research, there are several different ways that you can splice this, but I happened to stumble across these in some other fellow YouTubers' videos. And a lot of electricians actually who have their videos online, they like to use these Polaris taps in lieu of a lot of other ways of splicing wires. And as you can see here, these taps they're insulated, and that's the spot where your wiring goes, and they've already got the goo, as it's called, inside the connector to help with keep out moisture and things of that nature. And these caps you see here cover up the little Allen set screw that's in there that you tighten the set screws down with in order to secure the connector. So when you're done tightening, you put these caps back in place, and then again it helps maintain a nice weather resistant package. Now this will be underneath the house. This may be considered overkill, but I actually liked seeing how these taps are being used in lieu of other methods. But again, this is not a how-to video. Feel free to use whatever makes you comfortable, but I'm going to use, once again, these Polaris taps, and these are black ones that are meant for stranded cable. And you can see the size range there. It looks like it goes from 4 gauge, as big as 4 gauge, to down as little as 14 gauge. So what we're going to do, we're going to continue to work on this box, and then when we have all of our cabling in and we've got our splicing done, we'll bring you back. And welcome back. I'm going to use a flashlight here to hopefully give you a little bit better light as to what's going on here. You can see we got our 3 Polaris taps installed, and you'll also notice that we installed a box extension onto this 4-inch square box. I usually like to do that just to give you some more real estate to work with and some more room to kind of tuck wiring in, especially with these larger gauge wiring. You can see that we're dealing with 6 pieces of 6 gauge wire plus a ground, and as you can see, it doesn't take long before you start eating up the available box space that you have. Now, seeing as we are using a metal box, we did bond. You can probably see it. Let's see if we can get it to where you can see that ground screw. But you see a little bit of ground screw, yeah, right in through here. Looks like you can kind of see it there at the top of the case. Yeah, there we go. Right there. You can see that ground screw is screwed into the top part of the box and linked into the ground wires that were also tied together. And you'll see just a green wire nut up there for that one. And usually what I like to do, you'll have to pardon the camera work because I'm laying on my back reaching for equipment at the same time. And normally what I like to do when I'm doing a ground like this is to just take a meter in continuity mode, something that will make noise, such as what you hear here, and put 1 lead on the box, and I happen to have a ground wire that's running alongside this. And once I get a good connection here, there we go. And you can see that we got a tone. That at least lets me know that the ground wire is intact. And it lets me know that we got a good ground connection on this metal enclosure. Again, from what I'm seeing online, per code, as you make an entry into this box, they want the metal box bonded to the ground. And again, I'm not a certified electrician, and this is not a how-to. This is just kind of what I researched and what I've done here. Nice little 4-inch box extension. As you can see, kind of gives us just enough room to get all of our wiring up there in our taps. And then what we'll do is we'll finish this off by just putting a blank cover plate, 4-inch square cover plate on the front of it, and that'll finish it off nicely. But those Polaris taps worked out quite well. We'll go ahead and finish up a few minor things here, such as putting a couple more staples into our wire to support it on the rafters. And then when we're ready to do the wiring into the solar panel breaker box, we'll bring it back. And just want to bring you back, just so it didn't look like a cliffhanger. We did tighten our clamps for our cables, both sides of our box. And as you can see, we did finish up the box by putting that blank cover plate on. So the splice is accessible and serviceable. Should we have to make changes to it, or should it need to be serviced for any reason, we do have easy access to it. And this will finish up the this box, or this particular install, or what we need to be inside the crawl space for. And then we'll bring you back when we do the connection into the breaker from the solar system. I'll bring you back in a bit. And welcome back. As promised, I just want to show you the shot of the inside of the solar panel here, where we made our termination into our 50 amp breaker. And you've probably seen this panel before. This is just obviously an inside shot of what you've seen in some of the previous videos where we were redoing our battery bank, in which we do have some additional videos come along with this battery bank. We have an additional 32 100 amp hour cells that we will be getting set up and configured and added in to, again, kind of boost our capacity, as well as give us the capacity that we're going to need to compensate for the garage now being wired into the solar system. But we'll go get a shot of the garage, and we'll bring you back.
And this is the panel as it sits in the garage. And yes, this is vinyl siding. When the garage was built, as you can see, it was just added onto the house. So the exterior, or a large portion of the exterior wall in the rear of the house, became, as you can see here, one of the walls to the garage itself. And as you can see, when they put the panel in that feeds the garage, they installed it into the wall rather than flush with the wall. So that's what added to, as we were talking about earlier, the reason why we did the tap splices is trying to either pull all this vinyl siding off and then the OSB board underneath to run a new fresh feeder pair would have been extremely problematic. You'd either had to do that, or you'd had to go to the inside of the house and pull a large section of sheetrock down to gain access to where this panel is at, and then to be able to do things like pull the old staples and such out to get that old feeder pair out. So again, that's why we opted just to go ahead and do those tap splices on the bottom. But just wanted to close the loop on that and kind of show you why it would have been just a little bit difficult to try to pull that line out and run a completely non-splice line. But as you can see, the garage lights are on. It is tied into the solar system. Seems to be working quite well, and we'll bring you back with additional updates. But hopefully you find this video helpful. And once again, I'm not an electrician. This is just the way I chose to do it, and I take responsibility for those choices. If you should always contact an electrician for any project, especially if you feel uncomfortable in doing the work yourself. And hopefully this video was helpful, and we'll chat you later. Bye.